Imagine walking into an international airport, flashing a plastic badge, and strolling straight past the luggage scanners and TSA agents directly onto your plane. For decades, this is exactly how corporate cybersecurity operated. It's a model known as the castle-and-moat. You build a massive, heavily fortified digital firewall around your company's network. The assumption is that the bad guys are kept outside, so anyone who makes it through the front gate is automatically trusted and allowed to freely connect to servers and data. But if an attacker manages to slip past that single outer defense, they have the run of the entire kingdom. Let's say Helen from accounting is sitting at her desk, physically inside corporate headquarters. She has the right credentials and is authorized to be there. But overnight, her laptop is suddenly compromised by a hidden malware infection. Helen isn't the true threat, but her device is. Because the network trusts everything on the inside, that malware can quietly move from Helen's laptop to the payroll server and then to the customer database. It never trips an external alarm because it's already past the moat. Trusting a connection just because it originates from a desk inside the building is a critical vulnerability. Fixing it requires tearing down the castle completely. The replacement is built on a simple philosophy: never trust, always verify. Welcome to Zero Trust. Zero Trust operates on 3 core rules. The first is to verify explicitly. Instead of authenticating once at login, the system constantly interrogates every request, checking user identity, location, and device health. The second rule, least privilege access. Users get only the minimum permissions needed. If you need the email server, you connect to just that app. The third rule, assume breach. The network operates under the assumption that attackers have already compromised the environment. Together, these rules abandon the idea of a static defensive wall, replacing it with a system of continuous, active interrogation. To actually build this, engineers rely on technical frameworks like NIST 800-207. The core is the policy engine, a central brain crunching real-time data on user and device health. If approved, it signals the policy administrator, which builds a bridge to the requested resource. This leads to the policy enforcement point, finally letting the data pass. This decentralized setup acts as a trust broker. It ensures that network access is a temporary, constantly evaluated privilege, rather than a permanent right. Even with all these checks, breaches will happen. Someone will eventually click a bad link. Zero Trust divides the network into isolated zones, called micro-segmentation. When malware tries to spread from a compromised node, it hits a tightly sealed perimeter. By trapping the threat in its tracks, the system limits the blast radius. A potential catastrophic company-wide failure becomes a minor, isolated incident. The old medieval wall failed because the modern digital landscape completely outgrew it. When the COVID-19 pandemic hit, millions of employees took their laptops and left the corporate office. With workers operating from living rooms and applications hosted in the cloud, there is no centralized network router to defend anymore. The new security perimeter is the individual user's identity. Being inside the network no longer means anything because the physical office no longer holds the data. You can't buy Zero Trust in a box. Transitioning an existing network is a highly methodical journey. This NIST flowchart outlines the process. It starts with a comprehensive assessment, identifying every hardware asset, user identity, and required business process. From there, organizations deploy precise policies and shift into continuous operations, constantly monitoring to adapt to new risks. It requires a complete redesign of how data flows, but it's the only way to stay ahead of modern, highly sophisticated cyber adversaries. In a borderless digital world, trust can never be given by default. It has to be continuously earned. If you want to keep exploring the architectures that run our modern world, make sure to subscribe to What Is Defined for more elite cybersecurity intelligence.